Okay, so for this problem, here's how I would set it up. So they're talking about a racetrack, which is like a, oval. When you're on a racetrack, you start and stop at the same point. So then you're getting into the problem of like zero displacement. If you think about it like this, here's the racetrack like that. So the car goes around like that. What's the displacement? Zero. So here's how I'm going to think about it. I'm going to think about this problem. And by the way, notice they're using the word speed. Speed is scalar. If you go around a racetrack, if you start and stop at the same point, what would your average velocity be? Zero, because your displacement was zero. But you'd have a speed because you traveled a distance, right? Speed uses distance. So I'm gonna think about this problem like this. This is just how my brain works. Maybe your brain works the same way. So they tell us that the total length of the track is 1,600 meters. So imagine taking this racetrack and like opening it up so it's straight. So this total distance here is 1,600 meters. So from here to there is 1,600 meters. But now, what do you notice about the speeds they give us? Are the speeds using meters or kilometers? They're using kilometers. So instead of going 1,600 meters, I would go 1.6 kilometers. Okay? And then they talk about the first half of the track, so the halfway point. So I'm going to break this into like part 1 and part 2. So what would be displacement 1 for the first half of the track? 0.8 kilometers, which is 800 meters. Displacement 2 for the second half would be 0.8 kilometers. All right, what is... They're using the word speed. I'm just going to use V for velocity. Guys, speed and velocity are oftentimes used interchangeably. You'll notice, possibly even in chapter 2, but definitely in later chapters, even the book will use the word velocity when they should use the word speed, because technically if you use the word velocity, what should be specified? A direction. So, if you're really on your A game, you'll notice that. You're like, shouldn't they use the word speed since no direction is specified? So I'm just going to use V, even though they're using the word speed. All right, so V1, the first half lap is accomplished at a average velocity of 230 kilometers per hour. So notice I'm just kind of like laying out all the data just so it's more clear. All right, velocity 2 for the second half lap, that's what we're solving for. This is our question mark. The question is, what minimum average speed must the car have in the second half of the event in order to qualify? Okay, so T1 and T2. All right, now they tell us that in order to qualify for the entire thing, for this entire journey, what must the car have? An average velocity of 250 kilometers per hour. Okay, so I'm going to break it. Here's how I thought about it. The first thing that I solved for, let me shrink this down so I got some room. What? This string, and now I got room to work. Okay, so the first thing I solved for is I found the minimum time for the whole lap, for the whole the whole thing, for the whole course, for the whole 1.6 kilometers. Okay, so how do we go about finding the minimum time that the car must go from the start all the way to the end of the first lap? How do we do that? Well, what's the basic definition of velocity? Displacement over time. So that means that time, just do the algebra, what's time going to be equal to? Displacement over velocity. What's the displacement for the whole course? 1.6 kilometers. And then he needs to have an average velocity of 250 in order to qualify. The average has to be 250 kilometers per hour. So then the kilometers cancel, and we get 0.0064 hours, right? And it's so small because it's in hours. That makes sense? And don't round here. Don't round yet. You want to use the full number. All right, next thing that I want to calculate is the time for the first lap, which I labeled right here as T1. Can we solve for the time for the first lap? Yeah, doing the exact same thing. We're going to use this exact same equation right here. All right, so T1, the time for the first half lap, is going to be x over v. What was the distance for the first lap? I'm sorry, the first half lap. 0.8 kilometers. And we're told that the first half lap, he had an average velocity or average speed of 230 kilometers per hour. Like that. So in the first half lap, the time that went by was 0.00, and don't round this, 34782 hours. Okay? So we now have this guy. This is no longer a question mark. This is 0.003478 hours. So now, guys, we're almost done. Now we can figure out what T2 must be. How do we figure out what T2 is? The time for the second half. We're going to take the time for the whole course. That's the time for the whole course, and subtract away the time it took for the first half lap. Does that make sense? We're going to subtract those two times. Subtracting those two times gives us T2 as 0.0029218. Okay? And now we can answer the question. We're looking for the average velocity or speed that the car must have for the second half lap. So how do we find this V2 here? X over, so it's V2 is going to be X2 over T2. X2 is 0.8 kilometers. T2 is 0.0029218. And we get V2 as, just rounding it off, 274 kilometers per hour. It's like 273.8. And that's the answer. Yo.
What would you accept on like the test or quizzes? What's the leeway, like for rounding?
Oh, well.
Does it have to be that direct answer? Or
No.
Like plus or minus one?
Put it this way. If you show your work, in a way where, in fact, it's like, see here, like what I did is I wrote minimum time for the whole course. Guys, on a test or a quiz, it is a super good idea. Don't just start writing equations, because then I got to figure out what you're doing. Like that's what I did when I was a physics student. I would just go, okay, here's me solving for minimum time for the whole first lap. Here's me solving for this. If you show your work and it's obvious to me that you did the problem correctly, there's a lot of leeway. You could even get the answer completely wrong. If you made a little algebra error or wrote something down wrong, you'd still get like 90% of the credit on a free response. On a multiple choice, then the answers are far enough apart where on a multiple choice I wouldn't have like 274, 274.1, 273.9. Because then it becomes a sig fig question. Then it's all about significant figures. All right, let's do one more.